Hello, we're going to do the 1.3 note today, which is solving equations with variables on both sides. So first off, what is an identity? Let's go to the first vocab word, and really the only vocab word we have here. An identity is an equation that is true for all values of the variable. All right, so solving equations with variables on both sides. To solve an equation with variables on both sides, simplify one or both sides of the equation if necessary. Then use inverse operations to collect the variable terms on one side, collect the constant terms on the other side, and then isolate the variable, which is our solving part. So let's go ahead and look at example one. This is where our check step is really important. First thing I want to do is look at solving on both sides. So on the left side, there's no simplification needed. On the right side, there's no simplification needed. So now let's get all of our variables on one side. So let's do the opposite of minus 4x, which is plus 4x. And I get 10 equals negative 5x. Now I can divide both sides by 5, well, negative 5. And I'm going to get that x equals negative 2. I'm going to do a quick check step here. I'm going to my calculator. I'm going to see what is negative 10 minus 4 times negative 2. And on the right hand side, let's figure out what negative 9 times negative 2 is. So you put this in the calculator. I'm going to get 18 on the left side. On the right side, I get 18. And since they're the same, I check that off, and I know that x equals negative 2. Let's look at example 2. I'm going to zoom in a little bit easier to see. So first, we have to simplify. The left-hand side has a distributive property going on. So let's go ahead and distribute. And I'm going to get 9x minus 12 equals, on the right-hand side, I'm going to distribute. So when I distribute here, I'm going to get 8x, and then I will get plus 14. Now I'm going to keep looking, see if there's any simplification that I can do. And there isn't any. So now I'm going to put all my variables on one side. My trick is you look at which side has more. Is positive 9 or positive 8 the larger number? Whichever one's larger is the side I want to move everything to. So since the left side has more variables, I'm going to get rid of the ones on the right side. So I'm going to subtract 8x from both sides. And that's going to leave me with x minus 12 equals 14. Now I can add 12 to both sides, and I'm going to get that x equals 26. And do a quick little check step here. In the calculator, I want to type in 3 times 26 minus 4, and then figure out what is 1/4 times 32 times 26 plus 56. So that's all in the calculator. So put the left side in the calculator, I get 222. The right side, I get 222. Since they both match, I know that x equals 26 is my answer. Okay, so just for the sake of time right now, let's go ahead and just do on your own's number 1 and 2. So pause the video, and then when you are done, unpause it, and I'll tell you the answers. So 3, 2, 1, go. All right, welcome back. Let's see, for on your own number 1, you should have had x equals negative 2. And number 2, you had h equals, this one's a good one, 3/8. If you did a decimal, I would stay away from the decimal because there was a fraction in the original problem. But yeah, so just make sure you turn the decimal back into a fraction because there was a fraction in the original problem. All right, let's go to the next page. And let's talk about special solutions of linear equations. Equations do not always have one solution. An equation that is true for all values of the variable is an identity and has infinitely many solutions. Infinitely many solutions, also known as IMS. An equation that is not true for any value of the variable has no solution. So you may have had experience with these in the past. So again, we're going to be looking for problems that either have infinitely many solutions or no solution, or they do have an answer. So how this happens is this will always, always, always happen when the variable completely disappears or goes away. Okay, if the variable completely goes away in a problem, you're left with one of these two answers. If your variable stays, then you have an answer. So let's look at example 3. I'm going to zoom in here. I'm going to distribute and get 15x plus 6 equals 15x. Now I'm going to subtract 15x from both sides. And notice these cancel on both, and I'm going to be left with the 6 equals, well, on the right-hand side I get 0. Is it true that 6 equals 0? And that is no, not true. So we call that no solution. And there's no way to really check that right now. All right, let's go to B here. Let's distribute and get negative 8y minus 2 equals negative 8y minus 2. Now, a little shortcut here. I notice that the left side is identical to the right side. If two things are the same, then it's going to end up being infinitely many solutions. But let me just show you that worked out. First thing to do is add 8y to both sides. My y's cancel. I get negative 2 equals negative 2, which is a true statement, which means infinitely many solutions. Okay. If you'd have kept going and you added 2 to both sides, you would have got 0 equals 0. All right, so go ahead and let's go ahead and do the on your own. Let's go and do all 4 of them, and then when you're done, come back and I will tell you the answers. 3, 2, 1, go. All right, welcome back. Number 4 is infinitely many solutions. Number 5 is no solution. Number 6 is actually k equals negative 1/2. They threw a little curveball in there because you end up having a positive 10k on the left side, a negative 10k on the right. So when you move them from one side to the other, your k's don't disappear. Number 7 ends up being infinitely many solutions. Okay, let's continue on. Let's go to the page here. All right, some steps. Steps for solving linear equations. I'm going to zoom in here so you can read this a little easier. Here are several steps you can use to solve a linear equation. Depending on the equation, you may or may not use some steps. Use the distributive property to remove any grouping symbols. Distributive property to remove any grouping symbols. Blank the expression on each side of the equation. That is going to be simplify. Collect the variable terms on one side of the equation and the constant terms on the other side, and then we're going to isolate the variable and then check your solution. So that's what it is for multi-step linear equations, which we've done those. I don't know why this is now here, but that's where it is. So let's look at some story problems. Example number 4, a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Whoa, here's what we want to know. It does say the return trip takes only 2.8 hours because the boat travels 3 miles per hour faster. What we do know is if you're going downstream and upstream, the distance is the same. So the distance going up the stream we know is equal to the distance going down the stream. So that's one thing we know, same distance. But we also know that distance equals rate times time. So this distance is the rate times the time for going up is going to equal the rate times the time for going down because they equal the distances. So let's fill in what we do know from this. the distance going up. We don't know the rate, but we know the time. So the time is 4, and then it's 4 hours, but we don't know the rate. So I'm going to use R for rate maybe, equals. Now, the distance going downstream, it says the time was 2.8 hours. And then the rate said was 3 miles an hour faster, which means you're going to add time. So you're going to take the rate, the original rate, plus 3. So there's our equation. Let's go ahead and simplify this. I'm going to get 4R equals 2.8R when I distribute, plus 8.4. So then if I subtract 2.8 from both sides, sorry, 2.8R, I'm going to get 1.2R equals 8.4. And when you divide by 1.2, you get the R equals 7 miles per hour. All right, there you go. I'm going to not go do the on your own, number 8. It's the same thing. You're just changing it from a plus 3 to a plus 2, and then you're changing the time from 4 to 3.5 and from 2.8 to 2.5. So if you want to do it on your own, it's just going to be set up like this. You're going to have 3.5 R equals 2.5 times R plus 2, and then you have to solve that. So that's how you would set it up, which is the hardest part, and then solving should be the easiest. All right, if you have any questions, as always, feel free to reach out. If not, we'll see you here next time. Have a great one.